Algebra 1, Lesson 44. Part A is about adding fractions that have the same denominator. Okay, I just rephrased the title of this. Okay, so first we're starting out looking at fractions that have no variables. Just to remind you, you know how to do these. If you're adding two fractions and the denominators are already the same, you just add the numerators and keep that denominator. And then after you've added the numerators, if the fraction reduces, you need to do that because we always simplify our answers. So if we have 1/11 plus 2/11, we add the numerators, and that would be 3/11, and it doesn't reduce. So then that one is finished. Okay, so our rule for adding fractions that have equal denominators is to add the numerators algebraically and record the sum over that common denominator. So of course, we're in algebra, so we're going to start having sum with variables, but those variables are just standing in for numbers. So the same rules we've been using when it was totally number works whenever there are variables. So here in example 1, take a look at these denominators. They are all totally identical. So all we need to do is add and subtract the numerators as indicated here. So what we have is 5 minus 3 plus z all over that common denominator of a squared plus 7y. And then we simplify. Add the like terms up here. 5 minus 3 is 2, so 2 plus z all over a squared plus 7y, and that fraction is not going to reduce, so we're done. That's all there is to it. Take a look at example 2. These denominators are also identical, and now we add or subtract as indicated the numerators. Okay, so what we have here is this first numerator, 5x plus 7, minus this numerator, 3x minus 2. Put each numerator in its own set of parentheses. It was the first one minus the second one, and that is all over the common denominator, 5a squared x. And now we just simplify. First thing we have, we know there's an understood 1 here. This is a negative 1. We're multiplying times those. So we have 5x plus 7. Then we have negative 1 times 3x, so a negative 3x minus 3x, and then negative 1 times negative 2, which gives us a positive 2, so plus 2, over the common denominator. And then we add like terms. 5x minus 3x is 2x, positive 7, positive 2, 9, over 5a squared x. This won't reduce either. There is no common factor for the 2x and 9 for us to factor out and attempt to reduce it, so we're done. That's it for part A. In part B, the denominators do not start out the same. And so first we're going to look at this problem. We've been doing this kind for years. If we're supposed to add these, they have to have the same denominator first. So our first step would be to do 7 over 7 times 2/5 and 5 over 5 times 1/7. And our common denominator will be 35. Okay, so that means 7 times 2, 14 over 35 plus 5 over 35, and now that they do have the same denominator, we add the numerators, and if it reduced, we would do that, but it doesn't. Okay, the same steps need to happen when there are variables in the fractions. And so first we're going to read this. The fundamental theorem of rational expressions, also known as the denominator-numerator same quantity rule, That's what your book calls it. The denominator and numerator of a fraction can be multiplied by the same non-zero quantity without changing the value of the fraction. That's what we were doing here. We multiplied top and bottom by the same number because 7 over 7 is equivalent to 1. And so we didn't change the value of 2/5, we just changed what it looks like. Whenever we wrote it as 14 over 35, we could reduce that and we come right back to 2/5. They're equivalent. So that's what that rule in the box is saying, that we can do that. All right, so let's take a look at example 3 here that has some variables in it. Well, a variable in it. And we need to add these fractions. That means these fractions have to have common denominators. All right, so what we're going to do, we'll take b over b times the first fraction plus 2 over b here gets multiplied by 4/4. That way the denominator for both of those will be 4b. So now we have 3b plus 8 all over 4b. And this does not reduce. In order for it to reduce, there would have to be a greatest common factor of the numerator that we could factor out and then reduce. There's not. This is it. Okay, take a look at the other side. There are more. Example 4, these are all, we do them basically the same way. So here our least common denominator will be 2bc. All right, so we will have to take, this one just has a b, but it has to be 2bc, so it needs 2c multiplied. 2c over 2c times this one, plus, then for the second one we've got a c in the denominator already, we need 2b. So 2b over 2b times 1 over c, plus, this one's got the 2, but it needs the bc, so bc over bc times a half. Okay, so here we have 4 times 2 is 8, 8c plus, okay, so this is just 2b plus bc all over that common denominator of 2bc. And this doesn't reduce either. So that's it. Example 5. Okay, a lot of repetition here. So for this one, and you could try doing some of these, like pause the video, do them, and then see if we match up. For this one, we have an x in the denominator, but we need a b and a c. So bc over bc times 5 over x plus, this one has a b in the denominator, but we need cx. So cx over cx times x over b plus, the last one here has a c in the denominator, we need bx over bx times a over c. So we have 5bc, and you see bcx, bcx, bcx. I know I have common denominators, even though they're maybe not always written in the same order. They are the same denominator, so I'm going ahead and writing it as one fraction immediately. 5bc plus cx squared plus abx all over bcx. Again, there's not a GCF for all three of these terms. We cannot factor and reduce. That's all there is. On the next one here, we have a whole number. I'm going to go ahead and put that over 1. So when I'm looking at these, my least common denominator is the least common multiple of these three denominators. Remember, for the least common multiple, use the highest exponent. So these both have c's. We need the highest exponent. We're going to have c cubed as our denominator. The first fraction already has that, so there's nothing we have to multiply times that one. And we say plus. This one has c squared. We need another c. C over c times 4 over c squared. And then we have minus, and all this has in the denominator is a 1. We need c cubed over c cubed times 6 over 1. Okay, make sure I have a c cubed here. That'll give me a c cubed, and there's a c cubed. So all the denominators are the same. So now we have m plus 4c minus 6c cubed all over the common denominator of c cubed. And as long as I got the least common multiple of those denominators, I can be pretty sure I'm not going to need to reduce when I'm done. Still should check, but as long as you actually got the lowest common denominator, then that should be good. It'll save you some steps later. Okay, next one. These denominators, we have a 4, a 2, and a b. So the LCM of 4, 2, and b is going to be 4b. All right, so, and if you need to go back and review how to do LCM, we've just done that recently. 4b will be our denominator. We have a 4 in the first one, we need a b. So b over b times p over 4 minus. We have a 2 here, but we need 4b. So we have to multiply this one by 2b over 2b. Okay, and that's multiplied by a over 2 plus, this has a b, it needs the 4. So 4 over 4 times c over b. Double check these. There's 4b, there's 4b, and there's 4b. So we have our common denominator, bp minus 2ab plus 4c all over the common denominator of 4b. Okay, we only have one left. Take a look at these denominators. We need the least common multiple of them. Okay, so we have a 3 and a 4. The LCM for that would be 12. And all of them have c's. The highest exponent is a 4. So our common denominator is going to be 12c to the 4th. So taking a look at this first one, we need 12. And we need 2 more c's as factors. So 12c squared multiplied by that will give us 12c to the 4th. So we do that times a over c squared plus, all right, we have a 4. We need to multiply that by 3 to get 12. And again, we need c to the 4th. So we'll multiply that by 1 more c. So that's multiplied by 5 over 4c cubed. And then plus, we have c to the 4th. We just need to multiply to get the 12. So 4 over 4 times m over 3c to the 4th. Double check. 12c to the 4th. 12c to the 4th, 12c to the 4th. Okay, so the denominators are all the same. Oops. The denominators are all the same. And I can go ahead and write this as one fraction as I multiply the numerators here. 12ac squared plus 3 times 5 is 15c plus 4 m all over 12c to the 4th power. And we are done. Have fun adding fractions.